Before we continue on with logs, just take a couple moments here and indulge with me as we look at some applications of logs. You don't have to take notes on this page or the next page, but logarithmic scales are used of dealing with very large or very small numbers. Instead of using such large or small numbers, we instead can just look at the exponents. So decibels is an example of a logarithmic scale. And decibels are used to really measure sound intensity. So here I have a formula for decibels where I is the sound intensity. I sub 0 is the initial sound intensity. So let's say this is my initial sound, this is my new sound. And let's just say that my new sound is 10,000 times the sound intensity of my old sound. So just for the sake of simplicity, this is going to be 10,000. My new sound is 10,000 times the intensity. Well, if I look at this, what is log base 10 of 10,000? Well, this means 10 to what power is 10,000? That would be 4. So really in my equation, I have this 10 out front. Log base 10 of 10,000 is 4. So a sound that's 10,000 times the sound intensity actually corresponds to a change of 40 decibels. And while 40 might not seem like a large number, if you know that we're actually referring to the exponents, then a change of 40 decibels is pretty significant, which might make you think twice about listening to music at an incredibly loud volume. Another application of a logarithmic scale is the Richter scale. Here E stands for the energy released on an earthquake. So if you're looking at a 4 versus a 5 on the Richter scale, you might think, okay, 4 versus 5. But if you look at the Richter scale, these are actually the exponents. So a 5 actually corresponds to 30 times the energy released of a 4 on the Richter scale. And then if you read on the bottom here, if 30 times the energy is released, this actually corresponds to 10 times the shaking. So an earthquake with a magnitude of 5 is actually 10 times as strong as one that receives a 4. So just some kind of cool applications to be aware of in your day-to-day life. Let's start here. Write the exponential equation in logarithmic form. So pause the video, give this a try. Let's see what you remember from yesterday. Well, if you did this, if I want to write it in logarithmic form, my base is 4, so my base should be 4. What is a log? A log is an exponent. And then this would be my argument. So this is equivalent to saying 4 to the third power is 64. Today we're looking at common logs. A common log is a logarithm with a base of 10. If no base is indicated, it's implied that the log is a common log. This is very important. So in your homework, if I see something like this where there's no base, it's implied the base is 10. So I could just go ahead and write this as log base 10 of x. So if I see log of x, that's the same thing as saying it's implied my base is 10. Now on your calculator, you actually have a common log key, which would be right here. So if you punch that button, you can do any logs with a base of 10, common logs, on your calculator. So first example, evaluate the logarithms, then check on your calculator. So on all of these, I'll notice that there's no base written. I'm just going to go ahead and write in 10. If I don't see a base, it's implied my base is 10. And then just like yesterday, if I'm evaluating this log, I'd be thinking, well, my base is 10. What is a logarithm? A logarithm is an exponent. So 10 to what power is going to give me out a million? Well, a million has 6 zeros, so 10 to the 6th power would give me out a million, which means my answer is 6. So why don't you pause the video, take a moment to look at these other 3 examples, and let's see what you come up with. Now on part B, I might be thinking, well, what if I gave you this? 10 to what power is 100? That should be 2. So if I see 1 over 100, I'd be thinking my exponent, or that logarithm, should be negative. So my base is 10. a log is an exponent. I want to know what the exponent on 10 is. That would give me 1 over 100. Well, again, 10 squared is 100. So 10 to the negative 2 power would be equivalent to 1 over 100. Therefore, my exponent should be negative 2. So that's the answer to part B. Part C, 10 to what power is going to give you 1? That would be 0. And part D, careful. Sometimes people will tell me -1 here because 10 times -1 is -10. But that's not what I'm looking for. I'm actually looking for what the exponent is on 10. That'll give me out -10. So if you thought your answer was -1, here's what I'm going to tell you. If I take 10 to the -1 power, that'd be like 1 over 10 to the first power, or 1/10. So if I said, what's the log of 1/10, then yes, that would be -1. But 10 to what power is going to give me -10? That's actually not possible. So no solution here. If a base is positive, which it always is for logs, so if this is a positive number, there's no way I can raise a positive number to any power and get out a negative. So right away, if you see that the argument is negative, this isn't possible. Second type of example, this can be kind of tricky. What two consecutive integers are the following between? Only use your calculator to check. And actually, let's see, I didn't show you how to use your calculator on the last example, so let's do it on this one when we're all finished. Log of 7,598. Well, I don't see a base, so this is like base 10. Without my calculator, 10 to what power is going to give me 7,598? That's not going to be a whole number. But I need to figure out some logs that I could actually evaluate without my calculator. This problem's kind of similar to when we did this. Well, the square root of 9 is 3, the square root of 16 is 4. So if I asked you for the square root of 11, you would know that it's somewhere between 3 and 4 without using your calculator, because the square root of 11 is greater than the square root of 9, less than the square root of 16. So using kind of a similar train of thought, I'm going to pick something where the argument is just a little bit lower than 7,598. So I'm going to go log base 10 of 1,000. Or this is also like saying 10 to what power is 1,000? Well, 10 to the third power is 1,000. So this is going to be 3. But 1,000 is smaller than 7,598. So now I want to find an argument that's bigger than 7,598. So I'm going to go log base 10 of 10,000. Or this is like saying 10 to what power is 10,000? Well, that would be 4. So log of 1,000 is going to be less than log of 7,598. Log of 10,000 should be more than 7,598 since my argument is larger than that. So my answer should be somewhere between 3 and 4. Now, I did say you could check this on your calculator, so let's take a look at that. If I grab out my calculator, this is a common log. So here's my log buttons just to the left of the 7. So I'm going to type in log. I don't see a base. That means my base is 10. The number was 7,598. And sure enough, I get out an answer between 3 and 4. By the way, on the previous example, we did what? Log of 1,000,000. We said that was 6. You can check all of those examples on the previous page too if the base is 10. We said log base 10 of -10 doesn't exist. And sure enough, there you get an error. So use your calculator to check any common logs. Why don't you give this second example a try? Pause the video at this time. So when I attack this second example, I might be thinking, well, I would know, I'm looking at what 2 to what power gives me 1 over 20. So if I was just looking at 2 to what power gives me 20, I'd say, well, 2 cubed is 8. That's smaller than 20. 2 to the 4th is 16. Okay, that's still smaller than 20. 2 to the 5th. Okay, now that's giving me out something bigger than 20. But if I want to look at 1 over 20, so since log base 2 of 116 would be negative 4, and then down here we have 2 to the negative 5th would give me 1 over 32. Since these numbers sandwich 1 over 20, that means my answer should be between negative 4 and negative 5. By the way, when I'm asking for consecutive integers, it needs to be integers that are back to back. So I can't say between negative a million and a million. I need to find 2 integers right next to each other for my answer. Now, your calculator, if you have the new operating system, will actually do logs with bases that are not 10. So let me show you that quick. On your calculator, if I'm not doing a common log, you're going to have to go to catalog, so that's at second 0. And then if you just hit L or the parentheses key, you can scroll down to log. And then you should see a button that's just log base. Let's see, here we go. Yep, so there's my regular log key, and then I want the one that says log base. And if I hit enter here, it should allow you to do log of any base if you have the new operating system. So we just did what? Log base 2 of 1 over 20. And sure enough, my answer is somewhere between negative 4 and negative 5. So a little bonus here for you guys that are diligently watching the videos. You can actually check your answers with any base on your calculator. It's just a little more tricky if the base isn't 10, a little more time consuming. Third type of example for today is solve the equations, and again, only use your calculator to check. So yesterday, we maybe did stuff like this, where I could say, oh yeah, 8 squared is 64, I'm good to go, I can do that in my head. Here I might be thinking, well, 8 to what power is 4? I might not really be sure what that is. So there's a trick on these problems, very important, and it's changing the bases so they're the same number. So if I see log base 8 of 4 equals x, my base is 8. What is a log? A log is an exponent. X is my exponent. So I'm wondering, what's the exponent on 8 that would give me out 4? Well, I might immediately be thinking this should be something smaller than 1, because 8 to the first power is 8. So I might be thinking, well, my answer should be smaller than 1. And then the thing to note here is I could rewrite 8 and 4 as powers of 2. Or in other words, 8 could be written as 2 cubed. 4 could be written as 2 squared. And make sure I still have that x up here in the exponent. Now that I've rewritten these as the same base, on the left, I have 2 cubed to the x power. If I have a power to a power, I just multiply my exponents together. If I have the same base and these expressions are equivalent, well then wouldn't that mean that my exponents have to be the same? Or in other words, if these are equivalent, doesn't this exponent have to equal 2? So now I just set the exponents equal to each other since they have the same base, and my answer should be 2/3. Or in other words, 8 to the 2/3 power is going to give me out 4. So with this idea in mind of changing things so they're the same base, why don't you look at these last 2 examples, pause the video and give them a try, and then we'll compare. First thing I did on both of these examples was just rewrote them in exponential form. So now I have 2 to the x equals the 5th root of 1 to the 4th. Well, if I want to know really what this exponent is, I'm going to change that 5th root to just saying, well, the 5th root is the same as the 1/5 power. Now, I want these to look like they have the same base, because I'm not really sure otherwise how to do this without my calculator. So I might notice that 2 squared is 4, which means 2 to the negative 2 would be the same as 1/4. So this is equivalent to this. 2 to the negative 2 is 1/2 squared, or 1/4. Now, again, if I have an exponent to raise to another exponent, power to a power, I can just multiply these. And I see that I have the same base, so if these are equivalent, your exponents would have to be equal. So x has to be -2/5. On the second one, this is a common log. I don't see a base, which implies that your base is 10. So I rewrote this as an exponential equation. 10 to the x power equals, well, again, the 4th root is the same as saying the 1/4 power, so I might make that move. Now the left side looks a little similar to the right. I still don't have the same base though. However, 10 can be written, if I square it, 10 squared is the same as 100. So instead of 100, I'll replace 100 with 10 squared. I'm still raising 100 to the 7th power and then to the 1/4 power. So if I multiply all these together, 2 times 7 times 1/4 would give me, what, 14/4? Or 7/2. Now that my base is the same, the exponents have to be equivalent. So x should equal 14/4 or 7/2 or 3.5. Common logs.